Hey, what's up, Ziguanas? This is day 10 of the 30 Days of Z Coding Challenge. Join me as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new language. The name of the language is Zig. My name is Dusan. Welcome to Zignited. So yesterday I went through slices. So this first part from the documentation. Today I'm going to finish, so I think this is the last part of it. I'm going to go through these slice examples and try to wrap them up to move on to other things. And like I mentioned yesterday, so I think tomorrow I will apply things I have learned so far to create some example like TikTok game or something like that. So probably that's going to happen tomorrow. I will think if I will do this in the regular stream or I will do it maybe in the first part of the day and then later move on to the next topic. So I will think about this. So let's see what they say here about slices that we haven't covered so far. Using slicing for strings. Sig has no concept of strings. Yeah, I remembered that from the beginning. String literals are const pointers to null-terminated arrays of U8s. Okay. And by convention, parameters that are strings are expected to be UTF-encoded slices of U8. Okay. Here we coerce constant pointer to the slice of U8s with size of 5, 0 terminated, and the other one that is similar, but it starts, its size is 6 to const U8. Okay, let's see what they want to do. So they have, let's do this. No, actually, this is the second part where they coerce. I don't see. Maybe here under the hood, because I don't see anything like explicit. So I believe they speak about these two lines. So one is 5 characters long, and the other one is, I believe this is Chinese, so 2 Unicode characters, which are not translated to 2 bytes, let's say like that. Because in Unicode it can happen that some characters require 3 bytes, some of them require 2 bytes, and so on. So I believe this is what they wanted to say here, that they have a string literal. So here with, let's say, ASCII regular characters that are at the beginning of the Unicode. I mean, they're all UTF-8, but these, let's say, standard ones that were the same in ASCII, they are at the beginning, so they require 1 byte per character. And these are more later, simply somewhere later in the Unicode standard, in the UTF-8. So I believe they just wanted to say that. So let's just copy paste. I mean, nothing special happens here, but just let's run the code and let's see if I can print them. And let's do them one after the other. So first hello. And then we have this hello here as a variable, actually as a constant, not a variable. And then we have the world. I believe then this is Chinese world, the word that means world in Chinese. And let's run. Yeah, so nothing unusual. Just want to see something. just to double check. So we don't need this part anymore. That was just some test earlier that I have done. So this is pretty straightforward, but what I want to do is also to print the type. I mean, we have explicit type here, but I want to do it in a different way. I want to do the type in this way. And the same for the other one. They're the same, but just to cover them both. And let's say type here, just to speed up the process. And yeah, I literally realized when I ran the code that I shouldn't have this as here. Let's see. Yeah, that's what they mentioned. That's the conversion that happens that they mention. Rituals are const pointers to null terminate arrays of U8 by convention. The strings are expected to be UTF. Okay, here we coerce to so they actually wanted to say the opposite. So this is the default. Yeah, actually, because I don't do anything with this, this is a literal here. So they coerce it to a different type. So let's just print the type of that as well. And that is going to be here, the type of hello and world. Okay, so it's a little bit ambiguous. So let's say here, I'll just do this. That's at least I have for that one. Something different. Yeah, so of course, because we here specified the exact type, that is the type that we have. And this one is constant pointer to a slice of length 5, null terminated of U8s, and we convert that to unsized. It's still U8s, right? And just to double check here, yeah, it is, of course. And it's just like it doesn't have size. And it's actually a slice of U8s. It's a little bit different. It's not exactly the same. Yeah, this is the array actually. So yeah, so I still struggle with the syntax that makes arrays and slices different. I'm still not accustomed to them. But yeah, so the first one is, so basically this is an array and this is a slice. So there is this, here you don't have space, here you have space, and here the constant's in front, here it's after the square brackets. So yeah, takes some time to get used to it. Okay, let's see the next thing. Var altogether. So they make an array of 100 elements that are U8. And they set it to undefined. Then let's see what else they do. You can use slice syntax. Let's actually copy paste this entire part. It's easier to look here. It's a bit larger. Okay, so you can use slice syntax with at least one runtime known index on an array to convert an array into a slice. So we did something similar yesterday. Let's just follow it through. So here they create a variable start, which is use size. So this is runtime known, not a constant. This is just to avoid the compiler error that we didn't change the value of start and it's a variable. Then we have a constant altogether slice, which they take this variable, which is an array, and then they slice it from the start, which is known in runtime, and it's open-ended. Okay, so let's then just print this thing. And let's print it in this way. I want to see the type and the thing itself. So here I will say any. Yeah, so these are all 100 elements, right? Yes, 100 of them. By default, that's the size. And 170. Why? So this is hexadecimal probably. Why 170? Let's see if I just make it shorter, just to see everything on the screen. It will still be the same, but okay. Why is this 170 by default or hexadecimal? I don't know if it's hex or they don't say anything about this. So these are those mysteries of the documentation. Yeah, they don't mention here anything. Let me see if AI can help, because this looks like something it can do well. So let me take the code from here and I will ask it. Okay. And let's just take this part here. Represents 170 for each byte of your undefined array, because how Zig, especially in debug modes, often handles uninitialized memory. Okay, here's breakdown. When you declare var okay, you're explicitly telling providing initial yes, okay. Okay, debug field patterns. In many programming environments and compilers, especially when running in a debug build mode, memory that is allocated but not explicitly initialized by the user is sometimes filled with a specific debug pattern. So it's a decimal, it's a hex AA. Common byte value used for this purpose. Yeah, I've never seen this before, so it's interesting. So basically just like a placeholder thing. Okay, so this is okay. I was just curious, now it makes more sense. Then let's move on. Here, string concatenation example. Let's do that one. Just let me examine first. So hello world, try FMT. I guess I have to, do I have to import this or it's in the namespace? Let's try to run, but let me first see how it works. Altogether slice. Okay, so it depends on this one. Then it takes two string that we interpolate with two inputs, hello and the world, which are from before. Okay, I have them uncommented. Should work fine. Okay, so this should concatenate two strings. And let's print it out. So it's hello world, right? That's the name of the constant. Okay. Yeah, it's hello world. I was just like pause for a second just to think about something, but it's hello world, and this is a string, so should be okay to put an S here. And I just don't know if this is going to pass or I have to import. Yeah, I have to. So I guess it's like this, just FMT. Just try. Where? Ah, okay. Let's say no module FMT. Okay, let's see where they import from. Ah, std FMT. Okay. Okay. So let's try in this way. And here it's std. It's cool that you can just import one thing and then dot notation and go deeper, or you can go, what does it say? Void. Find there no space left. Okay, I didn't want to try. This is just want to do things in a bad way for now without error handling, just to move on quicker if it's possible. Cannot format error union without a specifier. Okay. So this is here. And what is this exclamation mark? This is the new one. I've never seen it. Let's try with any. Okay, this worked. I got error, no space left. But why? Let's see what they did here. So I literally copy pasted, except that I removed try. Hey, Lear, how are you? I've just seen your message. I don't know when you wrote. Sorry, I'm not looking. I'm still not used to looking at the chat. Okay. So I can give it a shot with AI just to see why I'm getting this error. I'm not going to spend too much time here trying to see why I get this error. Copy paste again the entire code from here. Coding at 3 a.m. Yeah, that sounds like a good idea always. Okay, let's see like this. So I ran this code. I ran this code, let's say. And I got error. Actually, not an error, but I believe it will understand what I mean. Can sort the list by the value of its digits, even though you can't sort the list by the value of the digits, even though we did it already. Play with it, you will find the solution. Not maybe at 3 a.m., but yeah. Let me see, what does it say here? What am I working now? Okay, so this is day 10 of my Zig learning. So I've went through the basics like variables, data types, if conditions, loops, pointers, array slices, and I'm actually finishing slices today. So these are slices in Zig. That's what I'm dealing with now. I'm basically going through the documentation and trying to figure out things, because documentation for most of the programming languages is not something like a tutorial, so it's not that straightforward sometimes to understand things. Okay, let's see what the Gemini says for this error. Because the buffer provided is okay, it's too small. Okay, let's blah 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 blah. Okay, understood. You need to provide the buffer that is large enough. How? Let's see the size of the. Okay, where they use a large enough buffer. So let's try to literally copy paste it. I don't spend a lot of time. Just see if this works. If not, I will just refer the code and move on. Yeah, usually it's like this, like maybe I pasted over something in the wrong way. What does it say? Type void, found there, no space left. Yeah, it's the same, so it didn't help. Doesn't matter. Let's move on to the next thing. Yeah, like that, Lior. So in Python, it's more straightforward, like what you do. And in Python, you basically don't have a specific type that is a slice. So when you slice a string in Python, it's a string. When you slice a list, it's a list. Here in Zig, it's a different type. So it's kind of like in Zig, you have arrays, which are something like lists in Python, but they contain only the same type. So there's a difference between lists and arrays. And then when they slice an array, basically difference is that slice is part of the memory and a length, like in parallel. They're not together. It's a pointer basically and the length. And arrays have those two things built in. That's so far what I understood about difference between arrays and slices in Zig. Okay, let's go to the next example. So this one doesn't work. I'll maybe come back to it in the future. Let's try the next one. So this one does not work. Let's see what they do here. Generally, you can use UTF-8 and not worry about whether something is a string if you don't need to deal with individual characters. No need to decode. And instead of this, I'm going to print mem, so I have to install import this mem. Where is it from? I forgot. So mem is from std. Okay, so let's do std mem. Okay, they just actually want to see if it's equal, so I can just print it out and see if it's equal. Yeah, but let it be as it is. So I'll just put something like this and then do here this. What does it say? Duplicate struct where? I don't need that fm. Aha. Okay. So I wanted to say mem, not fmt, equals to std mem. Okay. And it's interesting that it says duplicate struct. So by default, it's a struct. So it looks like Zig is struct based. It's not object based. Hello world where, okay, here. That's because I commented out this part here. And that is the part that does not work. So I cannot even test this. But this would just say true or false if it's equal. So in this case, I believe if they manage to concatenate, it would be true. So I don't even need to do this. It's related to the previous thing. Then let's see the next thing. Here, slice pointer. What they do here? Bar array. Let's do first the part here. And I will comment out all these other things. Don't need them anymore. And let's see what they are doing. So variable array, which is an array of size with size 10 of unsigned integers with 8 bits. It's undefined. Then we create a constant pointer that gets the address of this variable. So this is a pointer. And then they basically ask if the type, so they are trying to test if the type of the pointer is this thing on the right. So like always, I'm just going to print it. I don't want to do testing yet. I'll just print if this is the case. So I don't need this part. I need these. Wait, I have 2 times the quotes. What did I do? So let's do it in this way. So let's say type is then this, and interpolate this thing. And yeah, it's the thing that they expected. So constant pointer. So basically this is nothing new. This is just like they repeated something that I did yesterday. Let's see the next part. A pointer to an array can be sliced just like an array. Okay, let's do this. Let's see what they do. So they create a variable start, which is useSize. So the size will depend on the architecture. Then the end, the same thing. Start is 0, the end is 5. Then they, this is interesting. So basically, if I'm not mistaken, this is a struct that they create like anonymous struct where they create an address, so a pointer out of these two, because if they don't, this will produce an error. A compiler will say, okay, you didn't mutate variable, so it will cause an error. So this is just like they create an empty variable that they will never use just to fulfill this requirement that you cannot have unused variables. And this is like, I noticed this yesterday or day before, that they treat this like a change. So it's not necessary that you have in the next line, let's say start equals and then some other value to make Z compiler satisfied. It looks like this also works. If you just like make a pointer out of it, if you use this address of operator, it's considered that you're kind of like mutating. I don't know why, but it looks like it's like that. So this is basically just for that. Placeholder variable, not placeholder, just like an empty variable that is not going to be used, so that this doesn't break the code, the first two lines. Then constant slice. Okay. They say it's PTR, so this one here. So they take the pointer that points to this array here, which is by default the size of 10 and undefined, which means it will have these numbers 170, which were the placeholders in the previous examples. So hexadecimal AA. So it's initially 10 elements in the array. We make a pointer out of it, then we slice the array using that pointer, using these two values. Basically, we take the first 5. So it will be then size 10, right? And if I print it, I should expect to see 5 times 170. Let's try and do this, and let's copy paste, because I'm lazy. So slice equals, and then we want to see the slice. Actually, I can do also the type. I'm just curious to see. Slice type here. Oops. Copied things and forgot that I copied. So slice here and slice here. What did I say? Can form a slice without specifier s or formatting thing. So slice here, because slice is a pointer, I can use this one, right? I think they said s, but I believe because slice is a pointer, I can. Let's try to use a slice, format it as a pointer, and here I don't need to do that, I believe. Yeah, it worked. And let's see. So let's print this in 2 lines, just to see it better. And this type is as well. I don't have any others, so let's run everything again. Let's see. So the last 2 lines are what I wanted to see. Slice is okay. This is the memory address because it's a pointer. This is not the content to the slice. That's why I didn't see 170, 170, because by default it's a pointer, so I get just the memory address where it is, and this is the type. So basically, if I wanted to get those 170s, I guess I can use the square brackets notation. So let's say slice square brackets 0, and this is going to be a number, so no need for a star there. And let's try to do this just to see if it's in. Yeah, 170. Okay. I just wanted to kind of refresh my memory and test what I did before today. Okay, it makes sense so far. The slice is mutable because we sliced a mutable pointer. So it's related directly to that. So let's see. We will not. So let's do this instead. Type of slice. I actually did that type of slice. I have it here, so I don't need this one. Slice 2 equals 3, and then of course this is like, I don't even need to do it, but let's just do it in this way. So slice 2. So the index 2 should be 3, right? And we don't want to do this line at all. So we just change the third element of a slice into a 3, and then we print it. So this is nothing. I mean, the point here is that you can mutate the slice. So that's the point. That's what they wanted to say. So because we sliced a mutable pointer, right? So let's start from the beginning. So this was a variable array. Then we had a constant pointer to an array. And then we sliced here. So mutable, because we sliced a mutable pointer. So all the pointer itself is a constant. Because the array is mutable here, then automatically they say pointer is mutable. That's where this will take some time for me to get used to. It's not something that I would like intuitively understand in that way. So I would probably think that this cannot mutate. And I actually saw something similar a few days ago when I played with pointers, something not maybe applied to slices, something similar. Maybe it was applied to arrays. I forgot. But also something to me confusing like this part. Okay. So, and yeah, it was 3, right? Yeah, 3 down there. Let's do the last example from this huge chunk of code and see what they want to do. Again, slicing with compile time known indices will produce another pointer to an array. Yeah, this is from yesterday, I remember. So because this is constant, it's known at compile time. So pointer, in this case ptr2, they take the slice. So actually it's not only about this, this is the more important part, because they're not using, so here they are using variables that they implement here to make a slice. And these are variables, so because they are variables, they're not known at compile time. So this is what they actually wanted to say. So here, because I don't use variables, I have these fixed numbers. They are known because they're literals, they're known at compile time, which makes this pointer known as so the indices are known at compile time, and that's what's actually going to make this slice actually an array. So it's not going to be pointer, yeah, it will be a pointer to an array instead of, yeah. So many similar things which can be explained with words that kind of sound the same, at least similar, but they are completely different types under the hood, and they make like a huge difference. Okay, so let's see the next line. So they create the slice with constant values. Then they test what's the length of the slice. Is it 1? So it should be, because we start from 2, end up with 3, we're not including 3, so it's just like the index 2, 1 element. Then they ask if the first element is 3. So remember, it was like 175 elements at the beginning when we sliced, because the size was 5. And we had initially 10 elements, so placeholder 170. And when we sliced, it was 5. And then because we changed here the third one with index 2 to 3, so basically you're left with 170, 173, 170, 170. But then we slice again the same, we slice the slice, and then in this new slice, so this new pointer will actually use, okay, in this case it's not going to be a pointer to a slice, it's going to be a pointer to an array because it's known at compile time. But out of these 5 elements, it starts from the third one, and it goes to the element with index 3, which is basically not inclusive, so it just takes the third element. So it's a slice that contains only one element, and it's this one. So the number 3, that's why here in the new slice, because it has only one element, length is 1, and then on that new slice we see what is the first and the only element with index 0, and it is 3. So this should be true. And then let's see the last example. So we expect this to be true, but I'm not going to run it in this way, so I'll just print it. So we expect to see 1 and 3 here. And the last example, type of ptr2, and it should be the pointer to an array of U8s with size of 1. Okay, let's try to print all these guys, all these things. So I'll try to do them all at once in this way. And let's just do the simple thing. So I'm not going to say this equals that or something like that. I'm just going to do the interpolation simply. And here we need this. And to close it here, because I don't need this equal part. And then that right side, I'll just put here as an expectation so that we can double check. And let's run. I mean, in this case, running this is not the big deal. So it is what here was expected. Why here we have 13? Okay, this is why it's 170 slice. Wait, okay, this is because they're all in one line. So these are the answers. So actually, I forgot \n. So 1, this is the one from the answer. 3 is next to it, and then this part, because I forgot to go to the next line. Keep forgetting to do that. Right, as I was saying, like run this code is easy, piece of cake. Yeah, basically it is. So this is not the hard part. The hard part was, not the hard part, but let's say harder part was to understand what is to be expected and why. Okay, so this is pretty much clear. Let's move on to the next part. Let's see what they have here. So I'm not going to do this. I basically covered all these 3 topics. I didn't go maybe till the end of them, but I did cover them. Let's see this one. Sentinel-terminated slices. The syntax with square brackets and colons. So the X is provisional number, I guess, and type T is a slice which has a runtime known length and also guarantees a sentinel value at the element index by length. Okay, the type does not guarantee that there are no sentinel elements before that. Sentinel-terminated, that's why they say Sentinel-terminated, because they just guarantee for the end. Allow element access to the length index. Okay, let's see the example. These are the lines. Okay, Lior, have a good night and see you tomorrow. Yeah, in a few hours, basically. Not few hours, but soon. Bye-bye. Okay, let me see this part here, what they do, so I can basically comment out all these previous things. Const slice up to 0. So this is the type that we try to enforce, right? So the slice, and they say hello, then slice length equals 5, slice the last one equals to 0. Okay. Let me just read it one more time. Runtime long length. This is a bit confusing to me. Let me just try one more thing here. So I'll print all these. So let's copy paste this part here. So I want to do this part here instead. So let's say slice 5 equals this thing. And then, so it should be 0, right? We expect to see 0. And then the similar thing for the length. Slice length. Don't need this one. And then I just want to see one more thing here. Oh, this is 0, I forgot, but okay, and I'm missing the semicolons here. $104. Why now $104? Another placeholder or something. Let's see. I was expecting to see 170. That's why I actually did this test. Now it's changing. 104, 101. Ah, okay. Oh my God. I forgot that we are having the string literal. I thought we are doing the empty thing again. So in this case, it makes sense because they're actual characters of the... So the numbers representing characters. So if we do 2 and 3 here, which will basically be these two guys, they should be the same number. Yeah, 108, 108. Okay, now it makes sense. So let me just go back one more time here to this. I will copy paste this part just so that I don't have to move to a different tab. And I'm going to break this a little bit. Okay, and let's just put this as a comment. And let's read one more time. The syntax, this thing that we have here, is a slice which has a runtime known length. What they said about length, I didn't see, is 5. Okay. So it is correct length. So also guarantees a sentinel value at the element indexed by the length. Okay. So the element indexed by the length, so in this case 5, which means basically the element with index 5 is 0. So this is just like, I think this is from before when I played with string literals. This is just like, basically they are trying to say that they are injecting 0 after the string. So I think this is the point here. The type does not guarantee that there are no sentinel elements before that. Okay. So basically maybe you can have a string that has multiple terminating zeros. So it's not guaranteed that this is the only one. Sentinel-terminated slices allow element access to the len index. So if we don't do it, maybe we cannot do the dot length thing. So let's try that. If I do this, what will happen? Okay, it doesn't let me do that. Okay, so I'll just leave it and let's move on to the next one. The slices can also be created using a variation of the slice syntax. Start and end. The number, the Sentinel, where data is a many item pointer, array or slice, and X is the Sentinel value. Okay. Let's do that as well. Comment out this part. See, so it's an array, unknown size of U8s with these things inside. Runtime length you size 3, then prevent from compiler error, then on slice equals array, start from 0, go until 3, and Sentinel 0. Then the type of should be this one, and the length should be 3. Okay, so pretty straightforward. Let's do the copy paste thing one more time, just to do this. So this will be extra type, and then let's do the slice length from here, basically the same thing. It's zoomed in too much. And so expect to see 3, and here the type same. Okay. So just like this is the different part. You can actually specify where you start, where you end. So if you don't, it will take the entire thing, as I can see. And if I specify, it will just take that part, and then of course that will influence on the length and the elements. Sentinel, how many things are left? Okay, this is the last thing. Perfect. So let's try to wrap this out. Yeah, the last thing. Sentinel-terminated slicing asserts that the element in the Sentinel position of the backing data is actually the Sentinel value. If this is not the case, safety check illegal behavior results. Okay, let's see what they want to say by that. They have an array. Okay. Again, they create runtime size. They use the runtime length. Okay. Then they just like take this to avoid, and they expect some error, I can tell here. Let's see what they say. Creating a Sentinel-terminated slice from the array with length 2 will result in the value 1 occupying the Sentinel element position. This does not match the indicator set. Aha. So basically you have to say 1 is, yeah, this is, I think what they, yeah, I didn't even pay attention here. So the point was here that we had with size 3, it would take just like these 3 first elements, and then we say Sentinel is 0, which is basically the case. This is the first element after. And in this case, it will not match and it will cause an error. So let's just try to run this code as well here. So because we know it will break, I'll just run it immediately. I will not try to change anything. They don't try anything. Yeah, it's pretty clear. So let's run and see the error. What they say, Sentinel mismatch. Yeah, exactly what they said it should. And I guess if I say here Sentinel will be 1, that it shouldn't break. Let's test that. It didn't break. Like, yeah, because I don't print anything, it doesn't show anything, but it did not break. So let's actually copy paste these guys and just try to print. I cannot control slash. So let's see what I have here. Runtime length, slice. Okay, it can be like this. And I can also print the slice itself just to see the memory address. Just to play a little bit. Pointless discard of local constant. Ah, okay. Oh, this is also nice. I've never seen this before. Aha, so you're not allowed to do this. To discard if you're actually going to use it like I do later. Not only there, but here as well, and so on. So, let's comment this out. Run again. What is it this time? Aha. As any. Okay. What they say, slice without a specifier. So it's a slice where I print here. So it has to be pointer or any. And is there any visual difference? I forgot. I'll now do the second thing as well. So let's do one more time like any, just to see if they are completely the same at the output. Or there is some difference in formatting. Oh, if I use any, it will show the content. Okay, that's cool. That's cool. So I probably did this many times in the previous days, but I didn't pay attention. I was just focusing on basic things. And I didn't notice even, but now this is very cool. Yeah, it makes sense because you decide how you want to format it. Okay, now back to the original thing that we were testing. So yes, we were having this array, which originally broke when we sliced it here and said that we want to use the Sentinel to terminate with 0, because that was false, because here the element was 1. So I thought before that I'm actually setting this. I didn't understand it in this way, that you actually have to say what is after, like to explain what is the first element after. I thought you have to set it to the value that you want, but it looks like it's not that. So you literally have to say what is the first element outside. It has to match. And then in this case, because we fixed it now, it's not 0 anymore, it's 1, so it works fine. So this will pass, it will not crash. And then of course the type is this one, because runtime length is 2. So from 0 to 2 it's just like 0 and 1. So I mean index is 0 and 1, so 2, size 2, which is correct. It matches this number 2 here. And then when we just print the slice itself with the star formatting, we get the address and the type at that address. What kind of slice is it? And then if we use the any, it actually prints the actual values inside, which is pretty interesting. Okay, that is, I think, everything. Yes, so everything about slices in the documentation. Now, tomorrow, like I said, I will for sure do some, let's say I will do tic-tac-toe game tomorrow to practice things that I went through so far in Zig. And then maybe I will even make 2 streams tomorrow. I will think about it, so that I continue learning and covering the new things. So maybe I will first do the stream where I will write tic-tac-toe with only these things that I know. So just to remind you, I haven't touched functions, so I will not use them. I will just use some loops to make the game. And probably I will do that. So I will stream the tic-tac-toe, coding off tic-tac-toe, and then I think I will also stream one more time later to just like continue with these things. So maybe functions, or I don't know what's next on the menu. Maybe structs, maybe functions. I'll think about it. And that's the plan for tomorrow. Okay, thanks everyone for being here. And I will see you tomorrow very soon. Bye-bye.